Have you heard of object-oriented programming? It is also known as OOP in brief. In this lesson, we will explain what it is, and this will enable you to handle more advanced programming concepts. In addition, OOP is a stepping stone for explaining modules. We will do that in our next lesson. We can say every value in Python is an object. Integers, floats, strings, lists, they are all objects. Think of them as logical objects. Therefore, object-oriented programming refers to the concept of interacting with one or more objects. Today, there are several languages supporting OOP. Java, PHP, Python, and C++, for instance. The reason programming has evolved to this level is conceptual. Objects allow us to model real-world concepts. For example, we can have a list containing the exact number of visitors in a gallery for March. This is a list containing 31 data points, given that March has 31 days. Or, we could enter names of the galleries as string values in a dictionary called galleries. An object contains data, such as a number or a string, plus the operations allowing us to manipulate the data. Okay, excellent. The next thing we'll do is introduce the concepts of classes, attributes, and methods. Each object belongs to some class, defining the rules for creating that object, and we can attach a certain number of attributes to it. Let's use a metaphoric example that will make things much clearer. Uncle Archibald can make bikes, so he belongs to the bike maker's class. He knows the rules for creating a bike. This is a bike he made. Therefore, it is an object of the bike maker's class. As an object, it has certain attributes that refer to the state of that object. Its color, size, and type, mountain bike or road bike, are attributes that can be assigned to it. A method is something different. It is a consequential logic sequence that can be applied to the object. It could be an operation like turn left, turn right, slow down, or accelerate. These actions can be applied to the object, but it is important that, while programming, the focus is on the object and not the action, as it is in other types of programming. This is it. Let's provide a practical example that will help you visualize these concepts even better. We can create a list with 3 floats, and it will be our object. Sometimes, people will refer to objects with the word instance, or they may say properties instead of attributes. This is fine, as these terms can be used interchangeably. The object we created belongs to the Python's list class. One attribute of this list is the type of data in it. Technically, a list can contain various types of data, such as integers and strings. So, it is important to define the type of data used here. These are floats. A method we could apply to this object is extend or index, as we saw earlier in the sequences section. And please pay attention. These operations can be performed only after we have created the object. The difference between a function and a method is subtle and can be confusing. Try to remember, a method is a special function. As any other function, a method can have many parameters of various data types, but it will surely contain the object it is applied to as one of them. A method belongs to a certain class, while a function exists on its own. Looking back at our bike maker's example, if there isn't a bike that's been made, there is no way to apply the turn left method. One of the parameters of the turn left method must be a bike object. To avoid confusion between the terms method and function, the Pythonic syntax is different in the two situations. As we saw in our previous lessons, the method name is not just succeeded by parentheses. It is written after the name of the object it is applied to and the dot operator. Great! This concept will help you on your way to becoming a solid programmer. Let's keep up the good work and continue with the next video, where we will explain modules and packages. Thank you for watching. Hi, and welcome back. In this lesson, we will learn about modules, packages, and the Python standard library. The common thing between the three terms is that they all represent a different type of pre-written code. The idea is to execute this code during your work to save an enormous amount of time while coding. A module is a pre-written code containing definitions of variables, functions, and classes. Its charm lies in the fact it can be loaded in all new programs, and we don't need to rewrite the code manually at the beginning of a new program. It will suffice for us to just import this module. A package is pre-written code on a larger scale. It is a collection, or directory, of related Python modules. Technically, you could create your own modules and packages, but this usually requires high-end programming skills and a lot of time. Luckily, things are much easier than that. People in the programming community have developed a growing set of packages that are readily available for download and have been tailored for various types of professions and specializations. Sometimes people use the term library when referring to a package, so please know that the two can be used interchangeably. Great! Python's standard library is something a little different. It is a collection of modules available as soon as you install Python. Do you remember the built-in function len we used earlier in the course? We used it directly, and we didn't have to write down code manually, counting the number of elements in an object, right? Similarly, we used the methods from the list class to extend a list, and we didn't have to define a method on our own before applying it. Well, this was because Python's developers have prepared a certain amount of pre-written code that you can easily incorporate in your work. There is a set of modules there at the beginning of your program you cannot see, but it contains all those built-in features like the len function or the list class. Namely, these modules form the standard library. Being aware of what modules, packages, and the standard library are about, how can we have access to their pre-written code? Fortunately, Python has a broad practical application. To use the language, it is not mandatory to install all the modules there are in the world. People download the modules and packages they need. Statisticians will be tempted to install a module comprising a large set of statistical functions and methods, while a data analyst will likely use a package that helps them organize their data into tables, and so on and so forth. Apart from using readily available modules, you can also write your own modules. This indeed is one of the best features of Python. However, it is typically carried out by highly specialized experts. For instance, some developers will create a certain statistical module that can be imported and used by anybody. Since Python is open source, most modules are completely free and anyone can download and use them for their calculations. Once a module has been released, it is usually improved and updated. As we already mentioned, packages are a collection of modules. Therefore, packages are being developed in the same way as modules, but involve much more work. Some of the most widely used packages usually start as projects of a single individual, but are then carried aloft by the whole Python community. For instance, while working in the field of capital management back in 2008, developer Wes McKinney needed a high-performance tool for quantitative analysis. The package he created was Pandas, which today is one of the most successful data analysis libraries out there. Not only is it free, but is constantly improved by the community. This is what makes modules and packages a dramatic improvement in Python's efficiency. Once established and proven to be functional, a module or a package can be easily built upon and used multiple times, facilitating the work of sometimes millions of users. Great! To conclude, please remember that the Python standard library is a collection of certain modules that you can use later in your work. In practice, the part you need to learn on the technical side is how to import a module and packages in your file. And this is what we will do in our next lesson. See you there. And again, thanks for watching. There are 4 ways to import a module. In this lesson, we will show you all 4. And then once you have seen them, you can decide which one you will use when working on your own. To see how packages and modules work in practice, let's work with the math module from the Python standard library. Firstly, the math module contains multiple mathematical functions. Among them is the sqrt function, which calculates the square root of an argument. So, to use its features, you must import it. Let's see the 4 available options to do that. You can type import math.
Now the code of the math module will be run. To apply the sqrt function properly, we should respect the following syntax. Type the name of the module, math.operator, the name of the function of interest, sqrt, and an argument in parentheses. And we obtain the float 4. Wonderful! If you know in advance you wouldn't need all the functions and classes provided in the math module, and sqrt is the only function you'll use, you could type from math import sqrt. The syntax would allow you to omit the name of the module and the dot operator when calling this function. sqrt can be applied to the argument of, say, 25 directly, and you'll obtain the desired result. The third option we'll see is the one experts probably love the most. In advanced bits of code, you will see how modules or their functions can be renamed, simply because using shorter names can be time-saving. If we write from math import sqrt as s, we can use s instead of sqrt. Applied to 36, this function will return the value of 6. Great! Modules can be renamed too. Let's redo the first option. Type import math again and add as m. Accordingly, m.sqrt of 49 will result in 7.0. You see? The fourth option is usually frowned upon by specialists. Nevertheless, it can be appropriate for interactive sessions. Type from math import star, and all the features from math, functions, classes, or methods will be imported. Interpret it as import everything from math. To verify we did things right, let's apply sqrt to 64. Here's our result. Excellent! The problem is this option could be problematic for Python in some situations. Suppose you imported everything from math, and then you imported a second module that contains an sqrt function. And what if the second module uses the function differently? Which of the two should the software apply when you type sqrt of 81? Python will choose one of the two options, but you won't be able to select the one that should be applied. This is a sign of unprofessional coding, so it is avoided by experts in longer files. In addition, for further reference, you can read about the features related to the math module. Type help and put math in parentheses. A description of all the functions will follow. If you are interested in the meaning of sqrt, then you could simply type help open parentheses math.sqrt close parentheses. Nice! This will do for now. Thanks for watching. A programming language, its libraries, or just any other software tool that is widely used by people has documentation. What is that? Software documentation is a collection of information stored as written text, illustrations, or both, which accompanies the feature of the software tool and assists its users. However, this might not be as appealing as it may initially sound, because there is a significant gap between the level of a beginner and the advanced language used in the documentation. In a nutshell, what often happens is that multiple teams collaborate on the development of a certain software tool, and they need to keep track of various components and updates in the documentation at any given point in time. This entails the use of quite a technical language, which ends up being particularly confusing and unclear for beginners. So, you should know that even if you are an advanced user already, you might still encounter explanations that are very hard to understand when you access certain documentation. But this doesn't mean that you shouldn't use it as a point of reference. Quite the opposite, actually. It is just that sometimes you need a certain amount of experience in dealing with programming languages and their packages until you reach the level that allows you to easily navigate through the relevant documentation. Well then, if the documentation can contain all the information about a certain software tool, such as Python, why would you need to look around for more examples and applications of the language? Here's why. First, you might want to go through an introduction of how to use the relevant software tool written in an understandable, plain language. This can help you make your first steps and build up the confidence you need to become an advanced user one day. Second, and more importantly as well, the documentation doesn't normally say much about the practical aspect of using the framework in question. This means that it is so voluminous that it could be hard for you to evaluate what professionals would want to take from it, especially while dealing with external factors such as time constraints or abiding by the rules of best practices. In addition, other powerful tools of Python may actually be missing from its documentation. For instance, you will always have to balance between speed of execution, volume of memory usage, risk of losing your data, and making analytical decisions, while information for these and other factors might not always be present. To sum it up, it turns out that the documentation is the biggest collection of information for a certain software tool that is available out there. However, it is highly technical and theoretical. You would like to have an experienced user to show you how to read through it to extract the piece of information that will be valuable to you in a given moment. Since our mission is to help you become an independent user of Python in general, and Pandas and NumPy in particular, we aim to provide you with the right intuition. This will help you browse through the relevant documentation more quickly and efficiently. It is the same intuition that you'll need when surfing online on websites such as Stack Overflow. For instance, while searching for an explanation of a certain problem or error message you encountered while coding. On that note, just remember that as helpful as Stack Overflow can be for providing specific solutions and intuition, it is the documentation that has been written by the creators of the relevant software tool. The point here is that in case of conflict, the content provided in the documentation shall prevail. With that in mind, remember you don't need to shy away from developer documentation, even if it seems overly complex at first. Learning how to read it is a great skill to have. So, as the time you spend on it accumulates, this will help you become a proficient user of the given software tool in the long term. You really don't need to know much more about software documentation at this stage. What you rather need is to gain practice. That's how you can use the documentation to your benefit, and thus improve your learning curve. The next video will be more specific. We will, so to speak, make a tour of the Python documentation. See you there. Right, so in this lesson, we will take a look at the Python documentation. Before we begin, let me say how certain documentation has been organized may change over time. In other words, we can expect that people will update the website where it has been stored, or that they will improve the content and the way it is presented. Therefore, please focus on the essence of this lecture and disregard any visual and organizational details. There are a few ways to access the Python documentation. The first one is to go to the official website of Python, which is python.org. Then one option would be to click on Docs up here. Here it is. You just access the documentation, perhaps for the first time. If you go back, you can hover over this bar where it says Documentation and access the Python documentation by pressing that button. See? You just arrived at the same web page. Alternatively, you can just Google Python documentation to obtain a link to the same web page as a result. Whichever of the three ways you choose, you will end up here, which is the web page where the current version of the docs has been displayed. As a matter of fact, this is the place where you can get the most up-to-date information about all Python features. In addition, you can look around to see various tools that can improve your user experience. To highlight a few, let me start by saying that previous versions of the documentation of the programming language are continuously kept, and you're given access to them. For instance, in this column on the left, you can see which version is stable, which contains security fixes, and that the last one is, as usual, in development. When a version is in development, it means that it has not been finalized yet. That's why unless you would like to take a quick look into the future, you would normally like to use the latest stable version. At the moment of recording this video, this is the 3.8. If you'd like a full list of documentation versions, you can click on All Versions here, and then choose the one of interest. Otherwise, as you go back, you can also change the version by expanding this list and selecting the one you like. Since 3.8 is the latest stable version, let's go for that one. Another interesting piece of information, which you can find as you scroll down the page, is the FAQs. They contain answers organized into several subcategories. FAQs are very convenient because it allows you to quickly find additional information, if available. After you've finished with reading the FAQs, you can go back to the main page of the documentation by clicking on the documentation link in the top bar here. The last thing I would like to share with you about navigating through the documentation is the Quick Search button. It is located in the top right part of the screen. For instance, let's look for more information about tuples. Interestingly, the first few results don't even contain the word tuple. However, if you click on the first link that actually does contain this word, which is built-in types, we can access a page where information on tuples has been provided. Instead of scrolling down so much to get that piece of information, we can take advantage of the table of contents provided on the left and click on tuples. Great! Although the search button is very helpful, you have to take into account that it is the documentation itself that may seem to be organized in a very chaotic way at first. Therefore, you might need to spend quite a while before you know how to quickly obtain the information you need. Nevertheless, once you turn this into a habit, you will have probably the richest and most precise definitions of the given terms and tools at your fingertips, at least from a technical perspective. As an extra exercise, let's scroll back to the top and look for information about the extend method. Here's a new trick. Since the method we are referring to is one that applies to the lists class, the way we should look for it is by typing list.extend. As we do that, we obtain relevant information in the sixth result of our search, related to data structures in Python. When we click on the corresponding link, we can see an exact description of that method. Awesome! Actually, in many situations, Jupyter can help us obtain the information we need from the documentation in a much more convenient way. Let's go to the Jupyter Notebook file. Here we have created list 1, and we would like to extend it with the elements contained in a second list, list 2. Once we've typed the name of the list and placed the dot operator, we can press the Tab button. This will prompt Jupyter to provide us with a few suggestions on the methods we could use here. Since append starts with the first letter of the alphabet, it is logically on the top. Down the list, we can see extend as well. Click the Enter button from the keyboard to choose it. Then, open parentheses, and while you're still in them, type only the first few letters of the name of list 2. Then, use tab completion. This means you can press the tab button to obtain a few suggestions, one of which is namely the one you need, list 2. Select it and press Enter again. Referring to the Python documentation again, while your cursor is still between the parentheses, hold the Shift button and press up to 4 times the Tab button to obtain information about the extend method in different ways. I must admit that the documentation displayed by Jupyter is not as comprehensive as the one you can find from the official Python website. Nevertheless, this Jupyter tool is a real killer. It is extremely useful because it saves you the time to always go online and look for information describing the functionality of a certain method. As a side note, let me show you how this Jupyter tool also works for functions. For instance, as you type the string function, you can place your cursor between the parentheses, hold Shift, and press Tab to obtain information about this built-in function as well. Great! This is all we had to say about the Python documentation at this stage. Feel free to spend more time on it if you feel like, but better do so after you've finished the entire course and have gained the confidence of an independent user. Thank you for watching.